In this video, we're going to create a player character that can place and break blocks in the world. Right, so this brings us now onto the next part, which is actually getting a player character in here so we can explore our world and also start breaking and placing blocks. So to do that, we're going to make a new scene, pick other node, and we will use a character body 3D, and this will be our player. Rename that to player, and we can save this new scene. Player, of course, needs a collision shape. I'm going to use a cylinder. And for the size of the cylinder, remember that our blocks are 1 unit wide. So for the height, we'll do 1.90, oops, I meant to do 1.95. That way, if we're going into a 2-block gap, we will actually fit into it. Similarly for the radius, set it just a bit below half, right? Because we actually want to be able to fit between things. That done, I'm going to add just a node 3D. This will be called head. This will be a pivot point for our camera that we're going to add as a child of the head, and we're going to move the head up to actually be near the top of the body. This might seem very familiar for any basic player controller. Next, we're going to add a raycast 3D. This is going to be looking out from our camera and seeing what block we're looking at. And for that, we have to change the target position here. If you look at it, you can see it's actually casting downwards. We don't want that. We want to go out, let's say, -5 meters in the Z direction. So by default, or by convention in Godot, forward is considered to be the negative Z direction. So that's why it's -5. Finally, when we're looking at a block, we want to indicate to the player what they're actually looking at. And to do that, I'm going to add a mesh instance 3D. I'm going to call that block highlight. We're going to add a cube, there you go, a new box mesh to that. We're going to change its material, new standard material 3D. Go in there, we're going to enable transparency, set that to alpha, and go down to albedo, change the color, you can make that say yellow, give it a bit of transparency, and this way we're going to highlight the block that we're looking at with this yellow cube. You also want to change the size of the cube to be slightly larger than 1 meter. That way it'll actually envelop the block that you're looking at instead of kind of clipping into the block. So with that all done, we can now write a script for our player. So inherits character body 3D, call it player, create. Now I won't get too into detail here because a lot of this is like very standard for any player controller. Start by copying in my node exports. So you have, of course, our head, our camera, our raycast, and our block highlight. And I'm actually going to quickly save this, go back to Godot, build it, so that before I forget, we can set the head by dragging it in, set the camera, set the raycast, and set the block highlight. Then we go back into our script. Now I'm also going to define some parameters for controlling our character. So we have the mouse sensitivity, movement speed, and the jump velocity. Next, we need to track our camera X rotation. This is the rotation around the X axis, so that's going to be looking up and down. We're going to use this later to make sure that the player doesn't look higher than 90 degrees or lower than -90 degrees, so you don't like turn around backwards on yourself from looking up too much. Lastly, we're going to get the gravity, which we're going to get from the project settings so that it matches the gravity used by other rigid bodies. And as we did with the block manager, and this is going to come in useful later, we're going to get a static reference to our player. We're going to use this when we do infinite terrain so that we are tracking the position of the player and updating the terrain accordingly. Write our ready method that gets called when the player is added to the scene. We're going to track our player by setting instance, and we're also going to adjust the mouse mode to be captured so we can actually look around with our mouse. Next, I'm copying in the input method. This is basically for, you know, having the camera look up and down, look left and right. So this is rotating around the Y direction, that's looking left and right based on the X movement of your mouse, so moving your mouse left and right will rotate around the Y axis. And then, as I was saying for the camera, we make sure that any change in this angle wouldn't take us beyond 90 degrees. And if it wouldn't, then we can actually rotate the camera. Now we're going to do our process method, and this is where we're going to handle one, updating the block highlight, and two, actually breaking blocks. But now to do that, we need a way of actually setting a block. So we go over to our chunk script, scroll down to the bottom, and we'll define public void set block. And now what this is going to take in is it'll be a block position and a block. Go. What it's going to do is it's going to index into our blocks array. Whoops. Block position.x, block position.y, block position.z. And it's going to set that block to be the block that we've chosen, and then it's going to update, which will refresh the mesh and the collision shape. With that done, we go back to the player script, and now, firstly, the block highlight should only be visible if our raycast is colliding with something. In fact, we should check if raycast is colliding, and we do get collider, we get what it's colliding with. We want to make sure that that's a chunk. If you do is chunk, that just means that henceforth we now have this variable called chunk that we can actually use in this if statement. And maybe what I want to do instead is, instead of setting this way, we will actually say that if we're in here, so we're colliding with the chunk specifically, we'll set that to be true, else we will set that to be false. So now we're actually colliding with something. What we want to do first is, let's get the position of that block. So to do that, we do raycast.get collision point. However, this gives us the point on the surface of the block. We want to get a point inside the block. Now to do that, we will basically step inside the block by doing get collision normal, and we're subtracting half of the collision normal. So this is a normalized vector that points out of the face that we're pointing at. So if this points outwards, if we step in by half, we essentially get, around the middle of the block. But now we don't want around the middle of the block, we want, the exact position of the block itself. To do that, we're going to call this int block position, and we're going to really do it manually, really make 100% sure that we're actually rounding stuff properly. And to do that, we're going to floor to int, so it always rounds it downwards towards negative infinity. Now we do block position.x, mathf.floor to int block position.y, and then the same thing for block position.z. Now I suppose this can be a vector 3i now. Now, we have the block that we're looking at. First, we're going to adjust the position of our block highlight to be at that block. set it to int block position. However, we have to add on new vector 3, 0.5, 0.5, 0.5. And that's because our blocks in our chunk are sort of like defined by, one of their corners. However, this mesh instance here, you can see it's defined by its center. So that's why we just have to add that little offset. Otherwise, it'll be in the wrong position. Now, with that out of the way, we're going to do if input.isAction just pressed. Now, we haven't actually defined these inputs in our project yet. We'll do that right after. So first, we're going to check, did the player try to break the block? If they did, then we do chunk.setBlock, and we're going to do, we're going to have to cast this to a vector 3i, and it's going to be the integer block position minus the global position of the chunk itself, because this this value here expects the relative position within the chunk, whereas this is the global position in the world. So we do that, and now breaking a block is the same as placing a air block. So that's what we'll do there. Then similarly, if they have pressed the place button, which again we will define, then we will do chunk.setBlock, and I'll just copy paste, and we're going to set it to be stoned. And this is something that, if you want to continue working on this project on your own, you could set up an inventory system where you change what this value is, depending on how many blocks you have in your inventory and what you're currently holding and all that. However, the only thing is it's going to feel weird to be looking at a block and then right-clicking on it and we change that block. So instead, what we have to add here is plus raycast.getCollisionNormal. So it'll be whatever face we're looking at, it's going to move one block out in that direction, and we're going to set that block instead. So that's the block placing system done, at least for now. Next up, I'm just going to copy paste this in because this is just the movement controls. So, if the player clicks jump and they're on the floor, then they jump. We get the left, right, back, forward movement, move them based on which way they're facing. Now, this is all pretty standard. So, feel free to pause and copy down all that. Right. So now with that out of the way, we need to go back into our project and actually define all these movements, or inputs rather. So we go to our project settings, input map, add new action. So we have just our block commands. So place, we're going to bind that to the right mouse button. Break, we're going to bind that to the left mouse button. And then, of course, we have things like forward, which will be W, back, which will be S, left, be A, right, be D, and lastly, jump will be spacebar. So with all that done, if we go back to our level scene, we can instantiate a child node. We'll put in a player. Now, before I open up the scene, it's going to look really ugly. That's because we don't have any lighting and we don't have a world environment set up. So since this stuff is less specific to voxel terrain generation, I won't go into great detail. But basically, we're going to set up an environment for the background. Let's use the sky. We'll do new sky, set the material to be a procedural sky material. So now we'll actually have, a sky in the distance. And let's also add some directional lighting. We can make this cast shadows. So up here, let's turn it There you go. Now we can build. Going to play the scene. No main scene has ever been defined. Select one. We're going to select the current scene. Load in. And here we are. So we can move around as our player. We click on a block. We break it. We right click. We place a block. Now looking at these blocks, now that we've added the directional light and all that, you can see the lighting on them is looking a bit strange. That's because the normals aren't set up properly for the mesh. So we're going to exit out of here and make a quick detour back to our chunk script, where we're going to go down, and it used to be, right, that you could do surface tool dot generate normals, and this would just automatically create the normals for you. Last time I tried this, it looked really bad. It didn't actually change anything, and I'm not sure why. So instead, we're going to manually define the normals. Now to do that, I'm just going to copy paste in some code I wrote. I'm going to add it in down here. So what does this mean? Basically, if you do C minus A, so that's corner C to corner A, this is one of the edges of the face. Then B minus A, that's another edge. Now, since these are vector 3i's, I have to cast them to vector 3's, so I can take the cross product. Because if you take the cross product of two vectors that define a plane, you get the normal vector coming out of that plane. And just to be safe, I normalize the result. Now with those, in much the same way that we did for all the other triangles, we're going to define a list of 3 values. This is essentially, the normal vector for each vertex in the triangle. Now, since it's just a flat plane, they all have the exact same normal vector. Now we just add that to our triangles. We can do normals, 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 normals. And if you haven't used a lot of C#, the reason why I'm writing the name before doing it is because if you look at all these, it's a lot of optional parameters, and we're not necessarily doing them all. We're not necessarily writing them all in order. So with the UVs, I could just write UV triangle because, the UVs come after the vertices. But we're skipping over the colors array, we're skipping over this UV2S array, and we're doing the normals. So for that, you have to write the name of the parameter that you're setting, essentially. So now with that done, if we go back to the project, and we rebuild, then the problem should be fixed. And you can see, looking at the blocks, their shadows are looking a lot nicer. Now there's a problem in this that maybe you noticed when I was writing the code. If I start placing blocks like this, it's no longer working, and you can see I'm getting some errors in my logs. But if I go over here, I can place the block just fine. But now, trying to place a block here again, it doesn't work. Why is that? This right here is the boundary between two chunks. So when I'm looking at this block, I'm looking at that chunk over there, but now I'm trying to set a block in the chunk that I'm standing in. So that breaks, it goes out of bounds. To fix that, we're going to write another script. We'll use just a basic node. We're putting it at the top up here, same way that we did with the the same way we did with the block manager. It's at the top of our hierarchy so that it gets loaded before the chunks do. So again, the order matters. We're going to call this the chunk manager. So before the chunks do or after the chunks do? Well, now I'm not sure. Regardless, we're putting it up here. You have a new block manager. I'm going to create a script for it. Or not block manager, excuse me, chunk manager. Like we've done with a lot of our other things, we're going to put tool on this so it can work in the editor. And we're also going to add a static instance get private set, because we're going to want to use this in various different places. Now what this chunk manager is going to do is it's going to record the positions of all of our chunks, so that we can really quickly look up where our chunk is. To do that, I'm going to make 2 dictionaries. And it's complaining that it doesn't have the type. Click Show Potential Fixes. Now we could either use Godot.collections or use system.collections.generic. Make sure you use this. If this is written at the top of your project, if up here it said, using Godot.collections, you'd start getting some errors because it would conflict with this one. This is the specific one we want. So these 2 dictionaries, we have one that takes a chunk, gives you the position of the chunk, another that takes a position and gives you the chunk at that position. We're also going to want to record a list of all the chunks in our scene. And for now, we're using this class to better look up where the chunks are so that our player can properly place blocks. But in the future, this class will also handle the infinite terrain generation and updating the chunks as the player moves. So now what we want to do is we'll write our ready method. As we've done before, we're immediately going to set our static instance to this so that we can keep track of where this chunk is. Now we're also going to write a bit of LINQ or LINQ or whatever we call it. I should have looked up how to say it. So what we're going to do is we're going to get our parent, which is the level, then we're going to get its children. We specifically want the children where, let's say child is chunk. However, this is going to give us essentially an array still of just nodes. So we're going to do select, and we want the child as a chunk. So that'll actually cast the children to be chunks, and this will actually be a list of chunks once we cast it to list. So now we have all the chunks in the scene. We're actually not going to use this quite yet. That's my bad. I should have waited till later, but oh well. This is going to be very useful when we do the infinite terrain generation. What we really want is a way to actually update these dictionaries so we know where all our chunks are. To do that, we'll make a method called update chunk position that will take in a chunk. It will take in its current position and its previous position. What we're going to do with that is we will look at our dictionary of positions to the chunk at that position. We'll try to get a chunk that was at the previous position. If it exists, we will have it as a variable called chunk at position. And now if that chunk at position is equal to the chunk that we're updating, then we are going to remove it from our list. The reason why we make this check is, say at the start when we first load the project, and say we've generated a bunch of new chunks, and say they're all at 0, 0, then their previous position will all be written as 0, 0, but maybe another chunk is meant to be there where, and has already overwritten the fact that this original chunk was there, and then we end up removing that chunk. It'd become a whole mess. So we just make sure that we're actually removing the chunk that we intend to remove. And then aside from that, we just simply update our dictionaries. So our mapping of chunks to their positions, do chunk equals current position. And then the backwards mapping, we do current position equals chunk. And the reason why for this array we don't have to go and remove the previous value is because, we will always have the chunks that we have, and we will just be changing the positions they are at. But this array might not continue to contain all the positions that it originally contained, because if the player is wandering far off into the distance, the positions behind them will eventually no longer be holding chunks. So that's why we have to make sure we remove them. Now we have to actually call this method, and we're going to call it from chunk. So what I'm going to do is up here at the top, I'm going to define a new method called public void set chunk position. And actually, we're going to take these things in here. We're going to put them up there, right? Because we're going to keep reusing the same chunks, the same chunk objects. We're just going to reposition them around the player instead of, you know, deleting the previous chunk, creating a new chunk, because that's a lot of overhead that we don't necessarily need. So that's why we're going to generate and update as the chunk position gets set. We're also, of course, going to make sure that this actually takes in the position that it's being set to. We will say that the chunk position will be equal to that position. And now the global position will be equal to new vector3 chunk position.x times dimension.x, so times the width, 0 in the y, because we're not doing, you know, chunks on top of chunks. And then chunk position.y times dimensions.z. It's always a bit confusing when you're going between a 2D vector to a 3D vector, where here we intend this axis to be the same as the z-axis, but it's called y in a 2D. So yeah, don't get confused. And then, of course, we want to actually call our chunk manager method, where we do update chunk position, where this has been moved to position, and its previous position is whatever chunk position is currently set to. So there you go. And now here, instead of setting chunk position like this, we're going to use the method we just defined. Clean this up. So cool. Now we're actually setting in our chunk manager the positions of all the chunks. Now what we can use that to do is we'll define public void set block, which will take in a vector3i global position and the block that we want to set it to. Now first what we got to do is get the chunk that this position is in. So for that, I'm just going to copy paste this in because it's long. What this is the chunk tile position, where it is the global position divided by the width of the chunk. I'm casting it to a float to make sure that the division's actually nice, and then I'm flooring it to an int. Feels unnecessary to do all that, but I tried this before where I was just doing integer division and it was messing up. Maybe something else was messing up. Maybe it was this. Not sure, but I'm feeling a bit superstitious, so I'm going to leave it this way. So that gives us the x and y, x and z coordinate of the chunk itself. Now we're going to check our position to chunk lookup. We're going to see if it contains a chunk at that position. If it does, we're going to get it. And then we are going to set a block in that chunk, cast to vector3i, global position, right? So the global position of the block minus the global position of the chunk itself. And I forgot a parenthesis. And we will set that to block. So now if we go back to our player, and up here where we're placing the block, instead of doing chunk.setBlock, we're going to do chunkmanager.instance.setBlock. Now remember, this takes in a global position, whereas this one takes in a relative position. So for that, we just take out this part, where we're subtracting the global position of the chunk. And with that in place, if we go back to our project, just make sure we save it, hit play. Now if we go in here, I'm placing a block. I think this is, this is around where our sort of chunk boundary was. And you can see I've built right across the boundary without any errors.